Welcome back to AlgoJS. Today's question is LeetCode 583, delete operation for two strings. So given two strings, word1 and word2, return the minimum number of steps required to make word1 and word2 the same. In one step, you can delete exactly one character in either string. So with example 1, we have two words see and eat, and the delete operations to make these two words the same is 2. So we remove S and we remove T. And in example 2, the delete operations is 4 because we have to remove LE and also D and E. So the solution to this question is very similar to the longest common subsequence question. Now I've made a video on that, so if you want to go check that out, please do. But what we're going to do is very similar to the approach we took in longest common subsequence. So we are going to be using dynamic programming for this. So here we have the two strings from example 2. Now, like I said, we are using dynamic programming. This is going to be the bottom-up approach. We are going to be starting off with two empty strings here. Now, the reason we do this is because we want to set a base case for this dynamic programming. So here we are setting these empty strings here so we can create the base case. And that is setting each one of these initial values within this 2D array to 0. Now why have we done this? Well, L cannot be compared to an empty string, E cannot be compared to an empty string, and likewise two empty strings cannot be compared with each other. So we set all of this as 0. Now what we're going to do is we're just going to carry out the longest common subsequence solution. So we're going to be looking for the commonalities between these two strings. So we're going to be looking to see whether a character within a string is equal to a character within the other string. And then from that, we can deduce how many delete operations we need to make between these two strings. So let's run through this. Firstly, we're going to look at L. We're going to compare it to E. L is not equal to E, so it's not a common character. So we take the maximum between the left and above, which is 0. We do the same between L and T. We take the maximum because they're not equal to each other. Do the same for L and C and L and O. Then we move to E. E is equal to E. So we take the diagonal plus 1, which gives us 1. Then we move over E and T. We take the maximum, so we're going to take 1 from this. And then we move along. We take the maximum between the two, and we do the same for O. We reach another E. What do we do when we find an E which is equal to the character within another string? Well, we take the diagonal and we add 1. Is E equal to T? No. So we take the maximum between left and above. Is E equal to C? No. Is E equal to O? No. We move down to T. T is not equal to E, so we take the maximum between the left and above, which is 1. T is equal to T, so we take the diagonal and we add 1. So it's going to be 2. T does not equal C. 2, and then 2 again. Now we get down to C, carry out the process. So 1, 2, we've reached C. We take the diagonal and we add 1 to that. So that's going to be 3. Move along, we reach O. Repeat the process. 1, 2, 3. We've reached O here. We take the diagonal and we add 1. Move to D. D does not equal E. So we take the maximum, which is 1. So the maximum between the left and above. D doesn't equal T, so take the maximum between left and above. D does not equal C, so take the maximum. And D does not equal O, so take the maximum. E is equal to E, so we take the diagonal and we add 1. E does not equal T, so we take the maximum. E doesn't equal C, so we take the maximum. And finally, E does not equal O, so we take the maximum between the left and above. So we have found how many characters are common within both strings, right? We have ETCO, which is equal to 4, right? ETCO, 4. These are the common characters within the string. So how are we going to work out how many delete operations we need to make? Well, what we're going to be deleting is this entire string, which is equal to 8, minus the 4. The entire string, which is equal to 4, minus the 4. And then we just add these two together. So 8 minus 4 is equal to 4. 4 minus 4 is equal to 0. So our answer is going to be 4. Okay, let's code this up. So let's first extract the length of word1 and word2. Then we need to create a 2D array. So we'll call it DP. So it'll be array.from. And we want to make sure that the rows are equal to the length of n plus 1 and the columns equal to length n plus 1. So array n plus 1. So we have that extra row. N plus 1, so we have the extra column, and then we'll actually fill all of these with zeros. So I know I said in the explanation that we'd fill the initial row and the initial column with zeros only, but it makes intuitive sense to fill all of them out, and I'll explain what I mean by that in a second. So we're going to create the loop, so let I equal 1. So this is what I mean. So if we take I as 1 as opposed to I being equal to 0, then we skip the initial row of zeros and we only update the following rows. And we'll do the same for columns. I is less than or equal to word1.length, I++. Do the same for j, so j is equal to 1. J is less than or equal to word2.length, j++. And if word1, I minus 1, so the character at this position is equal to word2, j minus 1, so the character within word2, dpi minus j, then we need to update dpi j to equal the diagonal plus 1. So dp I minus 1, j minus 1 plus 1. Else, we're going to take the maximum between the left value and the value above. So dp ij is equal to math.max dp I minus 1j dp j minus 1. So after doing this, we'll have a DP array fully populated, and the last value within the DP array is going to be the amount of common characters within both strings. So let's extract that. So common character is going to be dpmn. Now all we need to do is to subtract this variable common character from both strings and add those together. So word1.length minus common character plus word2.length minus common character, and just return this value. Okay, let's give this a run. Let's submit it. And there you go.